Throughout Chapter 4, we're going to be looking at how we can describe bivariate numerical data. The usefulness of looking at specifically bivariate data is we're going to look for patterns between how two variables behave when considered together. Is it possible for one variable to increase while another variable decreases in a predictable pattern? Or maybe they both increase at the same time. These are types of things that we'll be able to answer by looking at the relationship between two variables. You might want to think about some variables that you think could be related. For example, height and weight, particularly in children, is often something that you can predict the weight based on a child's height. Perhaps something like shoe size could help predict your height in adults. So those would be relationships or variables that would have a relationship. As your foot size gets bigger, your height tends to also increase. Now, it's not a perfect relationship, but we're looking for any observations of related variables. We can also do things like consider in crime scenes the victim's age can be estimated based on a mathematical model that uses markers in somebody's blood. And it actually is quite accurate. You'll see that it's actually quite effective in this prediction. With this blood test measure that's on the x-axis and the age in the y-axis, you can see that as the blood test measure increases, the age tends to decrease. So older adults tend to have a lower blood test measure, and younger adults tend to have a higher blood test measure. And so seeing this pattern, we can be relatively confident that based on the blood test at a crime scene, that we can have a decent estimate for how old we suspect the victim to be. The first thing that we want to look at here is this idea of correlation. The questions here that we're asking is, does it look like there's a relationship between the two variables represented in the scatter plot? We're looking for a pattern. And if there is a relationship, is it a linear pattern? In this course, we're only going to be looking at linear models, but there are several other mathematical models that can be used to describe relationships. We can see in this scatter plot where on the x-axis it's the tannin concentration for different wines, and then on the y-axis it's the astringency rating that people provide for these wines. And you can see that as the tannin concentration is higher, the astringency rating is also higher. And this would be a relatively linear relationship because those dots, even though they do have some variation and some spread, they are forming a linear pattern. Now, this scatter plot does not have nearly the strength of a relationship. So this is looking at the mean blood lead level and the brain volume change. Yes, there is some pattern, particularly at the higher mean blood level rates, but other than that, it really does appear to be widely scattered around. In this scatter plot, we see somewhat of a curve towards the end, particularly here with these values, but overall, it does seem to have some linear relationship for most of the values. And then finally, for this scatter plot, we're going to see a quadratic relationship. Here, there's not a lot of values, but it is following this pattern where it decreases and then starts increasing again. And the last one we're going to look at here, there is very little relationship between the two variables.